Hello, my name is Siddharth Varde and this is Unity Advanced Answer 3. So the first question is, Mat2 Answer 3. The first question is which Unity tool would you use to observe performance and optimize several sectors of rendering scripts CPU, right? So the one word answer would be Unity Profiler. Uh, okay. The second question is how would you optimize the performance of your game? Explain different ways. This is a wide topic and okay. So uh, optimization, right? So it depends on the game to game, right? So like we need to first observe what is causing like what is not right for the optimization of our game. Let's say like have we not written the scripts properly, we are creating a new variables in methods like update or something, and like we are relying on the garbage collector too many and stuff like that. And then if we are not using the physics optimization stuff, so like all those things, like first we need to see what is the problem in our optimization, but then we can solve it. But most of the time the most time consuming thing for our mostly any game would be like rendering the objects on the screen, right? So to render the objects on the screen, so first of all CPU needs to collect the details of an object, what model it is, where are all the polygons, then which texture does it use, which like what is the shader of the texture, what material does it use. Then it will pass all like it will collect all the details, and these details are called as a render state. Then CPU passes this render state to the GPU, and that is this process to draw this entire object, and this process is called an draw call, right? So draw call is quite a heavy performance heavy thing, but render state is also quite performance heavy, right? It is even more it is even heavier than the like render state change. So like for a different object it will need a different material, different texture, different model. So like reading all these details from the hard disk is quite time consuming for CPU, for and doing it for like like thousands of the object can be quite time consuming, and it can affect our performance very badly. So uh, what we can do to optimize this, first of all, like we need to reduce the render state changes, right? So we need to reuse as much as shaders as possible. Then we need to reuse our textures as much as possible. So how we can reuse our like shader is simple, right? We use one simple shader for a lot of materials. Then we need to reuse the materials. How we can do that? Like we can use texture atlas. So it will reduce what is texture atlas? Many textures are like combined in a one texture, and then we are using that texture, and like we are using that texture inside a material, so we need a less materials and a less shaders. So in that way, by using texture atlas, we can reduce render state calls. Like it will be very helpful for our performance. And when we reduce the render state calls, then about reducing the draw calls, right? So how we can do that? To reduce a draw call, what we can use is like we can use occlusion culling. It's a rendering technique, so whatever that is visible on the screen, only that thing will be drawn on the screen. Then there is a static batching. So we need to mark any object that is not moving in the scene and stuff. We need to mark them as static. So all those objects will be rendered at once as a single mesh inside an Unity. So like it will take like very few draw calls. So then we can like we need to observe like which shadows can be soft and which shadows can be hard. Then we need to bake the lighting. Then yes, occlusion culling came. Then lighting came, then yes, batching like static batching came, dynamic batching is also another thing, where the smaller objects and that are repeated in the scene, those objects will be drawn together. So that is also another technique that we can use. Then GPU instancing is another technique that we can use. So what happens in this technique, that whatever there, like let's say there are objects that are not static in our scene, that are movable, so we can like GPU instantiate them, right? So what happens is, let's say that 10 of these enemies, like 10 of those objects in our game, so all of them will be since we have marked it as a GPU instancing on, so that like we can do it on material. So that object will be drawn, or like all the 10 objects will be drawn at once. So like that will also reduce the draw calls. So this is a very major factor. Then another thing is, like, we can use low poly okay, colliders. Yes, we can use low poly colliders for our objects. So like by that way we can also do that. We can use LODs, then we can use texture maps. So these techniques will help us to reduce the draw calls and render state changes. So like in that way we can reduce our like improve our performance of our game quite a lot, and we can make it optimize. Thank you.